Hi, my name is Anna. Welcome to this journey through the future of intelligent logistics. Today, we are going to study the chapter, which is Robotics and IoT for Inventory Management. In this chapter, we'll explore what robotics and IoT are, how they are revolutionizing inventory systems, and why these technologies are becoming essential in modern supply chain management. Let's dive in. Introduction to Inventory Management with Robotics. We begin by understanding how inventory management has evolved over the years. From manually counting stock with pen and paper to the deployment of sophisticated robotic systems, the transformation is astounding. Today's warehouses deploy autonomous mobile robots, AMRs, robotic arms, AGVs, and even drones for scanning. These technologies are not just futuristic, they are practical, efficient, and in active use. With up to 85% reduction in manual errors and over 60% improvement in operational efficiency, it's clear that robotics is reshaping the fundamentals of inventory control. The business case for robotic inventory systems. Why should businesses invest in robotic inventory systems? Because the returns speak for themselves. Though the initial investment ranges between $250,000 to $1 million, most companies break even in just 18 to 24 months. Robots reduce labor costs drastically and eliminate inefficiencies, operating 24/7 without fatigue. Accuracy also soars, with robotic systems achieving over 99% precision, far beyond the typical 65 to 75% in manual systems. The role of IoT in real-time inventory tracking. IoT brings a digital nervous system to inventory. RFID tags, smart shelves, and environmental sensors create a live network that tracks every movement and condition of inventory. Unlike barcodes, RFID doesn't need line of sight, making tracking seamless. These connected devices can even monitor temperature or vibration, making them ideal for sensitive goods. With IoT, companies reduce discrepancies by 95% and support lean inventory models like just-in-time. IoT-driven inventory visibility. Key components. Let's break down the backbone of IoT tracking into 4 components: data collection, transmission, processing, and action. Sensors constantly collect granular data on each item. This data is transmitted wirelessly to central systems using protocols like Wi-Fi, LoRaWAN, or 5G. AI then processes this data, predicts demand, and generates alerts or recommendations. The result? Managers get real-time insights and can make proactive decisions instead of reactive fixes. Automated stock replenishment with robotics. Stocking shelves isn't just a manual job anymore. It's automated. Robots now monitor inventory levels, place orders when thresholds are met, and even unpack incoming goods. Systems like automated storage and retrieval systems, ASRS, precisely place items for optimal retrieval. Digital twins mirror physical stock in virtual environments, providing unmatched transparency. This closed-loop ecosystem slashes stockouts and reduces the need for excessive inventory holding. The automated replenishment cycle. Here's how it works in action. First, inventory is tracked in real time. AI forecasts when stock will run low and automatically generates a purchase order. When goods arrive, robotic systems verify quantity and quality using tools like computer vision. The goods are then stored by robotic arms or vehicles in strategic locations. The entire process is frictionless and rapid, minimizing human involvement and error. Robotics for efficient order, picking and sorting. Order fulfillment is one of the costliest and time-consuming processes, but robots are streamlining it. Goods-to-person systems bring items to workers rather than having them walk miles. Cobots assist human workers, while vision-guided arms perform picking with pinpoint accuracy. These technologies not only speed up operations 2 to 3 times, but also reduce human error significantly. The future of picking is intelligent, agile, and robot-assisted. Advanced robotic picking technologies. Let's dive deeper into the tech. End effectors. Grippers of various designs allow robots to handle a wide range of items, from fragile to heavy. Computer vision enables object recognition even under poor lighting or obstructions. Swarm robotics allows multiple robots to coordinate and optimize tasks together. This system of collaborative intelligence allows massive throughput and near-zero errors. Companies like Ocado rely on these systems to fulfill thousands of orders daily. Integrating IoT with inventory control systems. IoT doesn't work in isolation. It must be integrated with existing systems like ERP, WMS, and supplier portals. This integration ensures that data flows seamlessly across all platforms. For instance, if stock levels are low, the ERP can automatically trigger a supplier order. Blockchain ensures data integrity across the system. Standardization and robust cybersecurity are vital for this kind of large-scale, interconnected ecosystem. Integration architecture for modern inventory systems. This architecture includes 5 layers. At the top is the user interface, dashboards, apps, control rooms. Then we have business applications like ERP and WMS. Middleware connects these systems through APIs. The decision-making layer uses AI and machine learning. Finally, the foundation comprises IoT sensors and robotics collecting real-time data. Together, these layers create a smart and responsive inventory system. The impact of robotics on reducing inventory. Errors. Human errors, like miscounting or misplaced goods, are a persistent challenge. Robotics eliminates these risks. Continuous verification, precise movements, and digital recording drastically reduce shrinkage, theft, and transaction delays. Compared to traditional methods that show higher discrepancies, robotic systems maintain nearly perfect records. This precision translates to better trust, fewer audits, and smoother operations. Optimizing inventory. Turnover with robotics and IoT. Inventory turnover is a key KPI. With AI, businesses can reposition fast-moving goods to improve accessibility. Predictive analytics fine-tunes inventory levels by forecasting demand, helping reduce overstock and understock issues. Reorder points are also dynamically adjusted based on live data like supplier delays or market trends. Examples like Unilever and Zara show how intelligent systems improve turnover by 25 to 40%. Case studies, robotics and IoT in inventory management. Let's look at some real-world success stories. Amazon's Kiva robots cut processing time by half and increased capacity by 40%. Ocado's Hive system operates with over 1,000 robots, achieving almost 100% accuracy. DHL took a hybrid approach, combining IoT, AR, and cobots to improve productivity by 25% and reduce training time significantly. These examples show that even different strategies can lead to measurable gains. The future of robotics and IoT in inventory management. The future is incredibly exciting. We're seeing micro-fulfillment centers powered by AI, humanoid robots with human-like dexterity, and quantum computing to solve complex logistics problems. Drones may soon fly inventory between facilities, and augmented reality will allow humans and robots to collaborate better. But to get there, companies must build digital foundations today and may consider robotics as a service models to lower initial investment risks.